and start recording and share my screen. Actually, let me share this first. Okay, so on Canvas, you guys have your topic for the day. So it says you're going to be able to describe the parts of the atom, calculate subatomic particles when you're given an isotope symbol, and describe isotopes. So here's kind of your questions. And again, none of this should be new information. So when I say characteristics of the atom, I'm talking about like, what are the 3 subatomic particles? Where are they located? What mass do they have? What charge do they have? All of that kind of stuff. Like, what does the atom look like? Protons, neutrons, and electrons. So if you're given a symbol or a name of an isotope, how do you calculate that? Or the opposite way, if you're given the protons, neutrons, and electrons, how do you figure out how to write the symbol for an isotope of an atom? And then just the last one is just what are isotopes and ions, because that has to do with our atoms having different numbers of neutrons or different numbers of electrons, depending on which one's changing. So you did have a note video here that if you haven't gotten to it, you can go back and do it later. But again, like I was saying, this shouldn't really be new info today. So it should just be a recap. And then your assignment that you're going to do today is a Google Slide assignment. So if you haven't done one of these in a while, then, or if you haven't ever done one, what you're going to do is it's going to pop up with a little preview down here. Excuse me. And once it loads, you'll see a preview, and then the title will be in blue, and you'll click on that blue title, and it will open it in Google Slides. It'll like force a copy. So right here's the title. It's not finished loading yet. You'll see it down here. There it goes. So you'll click on the title. It will open it in Google Drive. It'll open a copy for you. And once it opens, you'll see that the first slide's kind of a title slide where you can put your name. The second slide has the instructions for what you should be doing. And basically it tells you, if you see a keyboard, that means you're going to have to click in a text box and type in an answer. If you see what looks like a little mouse, you're going to have to probably click and drag some things from kind of a bank of options to fill in blanks or something like that, or to make something. And so it'll, as you go, it'll have, other, specific directions on each slide for what you're going to do. But the overall thing is you're either typing in things or you're clicking and dragging things, okay? This first one, which I moved this earlier and then I wasn't able to move it back, but so let's see if I can move it back now. But you have the answer bank over here, and it wants you to tell me where, like the proton, electron, and neutron, what's each one of their masses, what's their charge, and where are they located. And so you have the answer bank over here. I don't know why it keeps dragging all over everywhere else. And then as you go, the next one, it'll have you type some stuff on the next slide. Then it has some more drag and drop practice with kind of what does it look like on the periodic table. So if I see the symbol of an element in its little box, what are these numbers? Okay, you got 3 answers, you're only going to use 2, okay? And then the same thing here for when we do the symbol for an atom or an ion. What are all of these things called? So you got 4 choices, you're only going to use 3. Oh my God, am I losing my voice? And then there's some here where you're going to type in, so it says like, write the symbol of the element and the charge. So you will need a periodic table to refer to when you're doing this, because I'm going to have to look up the element by looking at the number of protons, because that's how I identify the element. And then the charge I get by comparing protons and electrons. Okay. So when I always do protons minus electrons, and that gives me the charge. So for here, 12 minus 10, that would be 2. So my charge would be a positive 2. But if electrons is higher, when you subtract them, you'll get a negative answer. And that's because the charge will be negative. Okay. Then you have some isotope practice with names. So there's an answer bank over here. And we'll talk about kind of, when we go through the notes and the examples, how do we figure out which name would be what, okay? Because you add these 2 together to get the mass of the isotope, and then that's what's in the name. And then the next one, it's a little more challenging because you don't have an answer bank. Now you're just typing, but you're doing the same thing, okay? Then you get into the symbols. So this one is where I'm giving you the symbol and you're telling me how many protons, electrons, or neutrons there are in there, and you have an answer bank over here on the right side. So there's a couple like that. And then the third one, now you're typing them in. There's no answer bank now, okay? The last part is the opposite. I give you the protons, electrons, and neutrons, and then you have a little answer bank where you have element symbols, and then you have all the little numbers for that would go around the symbol. And so you'll drag them and you'll arrange it so that it looks like kind of this example up here in the top corner. So that's your assignment. So what we're going to do now is we are going to do some examples together. So we go back to share screening again. Okay, so in your notes, can everybody see this? I'll make sure before I start going over it. Can you guys see the note page? Yes, okay.
Yeah.
Okay, thank you. All right, so just before we go over some of the practice, just to recap, this is kind of what it looks like when you do the symbol notation. The one thing I want to point out that is a little different than last year is we actually assign the atomic number and mass number, these kind of like letters, they're kind of like placeholders. So when you do a symbol, the element symbol we represent by X, and that's because there's no element that has the chemical symbol X. There's xenon, which is Xe, but there's nothing that's just X. So X is it's kind of like in math, it's kind of like the placeholder. So this is just a generic example for how we would write the symbols for these atoms. So we have X would be where we would write the chemical symbol of our element. And then the bottom number down here on the left side, it's represented by a letter Z. And it's kind of weird because the Z is for atomic number, whereas up here, the capital A, that's mass number. And it's kind of, you'd think it's backwards because, oh, why isn't A atomic number? I didn't come up with a naming system. So you can blame some old dead white guy probably, okay, for coming up with this system. But that's what you need to remember, that the bottom number that's represented by that letter Z, that's the atomic number. And the atomic number, as it says up here, is the number of protons. So if you know the number of protons, then you know the atomic number. If you know the atomic number, then you know the number of protons because they are always the same. The other important piece about that is that the protons, that gives the atom its identity. So if you know the number of protons, you know the atomic number, which means you can look it up on a periodic table and you can identify what element symbol it is, okay, or what name it is. So that's important to remember when we're going through and doing these. Somebody's in the waiting room. All right. She's getting in. So the mass number, which is the other number that's usually in here, is we have to calculate it. It's not going to be always very obvious. It's the protons and neutrons added together because those are the particles that have mass in the atom. Okay, electrons, their mass is so small, we say it's negligible, which I discussed in our note video. Okay, and so protons and neutrons are really the only things that contribute to the mass of the atom. And so mass number only includes those protons and neutrons. Okay. The other thing that's important to remember is if you want to find the number of neutrons, okay, you subtract the atomic number from the mass number. Okay. That's how you get neutrons. And the symbol is set up that way because if I look at how the symbol is set up, this is the mass number up here. This is the atomic number down here. If I put like an imaginary subtraction sign there, it's set up already for me to subtract it. So you can think about, the larger number up here on top, you subtract the smaller number on the bottom, and then, whatever answer you get, that's the number of neutrons, okay? For electrons, a lot of times electrons are the same as protons, okay? If you have a neutral atom, meaning your charge is 0, then that means that protons equal electrons, because that means that all of my positive numbers and all my negative numbers cancel out, okay? They're equal. However, if you have up here in the corner, if you have up here in the top right, a number, a plus or minus number, that's the charge. And that means that the protons and electrons are not equal. Okay, so if I have a number up here, like, maybe I have a 2 plus or a 3 minus or, whatever it is, it'll be a number and a symbol, a plus or a minus. That tells me that my atom has either lost or gained electrons. Okay, and it's now an ion and not a neutral atom. So what you need to know is that if that happens, the protons and electrons are not equal, okay? And if you need to calculate the electrons, what you do is, like, as I said when we were looking at the slide, you do the protons minus the electrons, that gives you the charge. So if I need to figure out like the number of electrons from the charge, then I can just figure out, let's see, if I need to do the electrons, let's see, I can, if I add the electrons here, that's plus E, and then so protons minus the charge equal the electrons. So if you're trying to figure out the number of electrons on something that has a charge, do the number of protons, which is your atomic number, minus the charge. And just remember though, if you have a negative charge, if you subtract a negative, what happens in math? So like if I have 2 minus -2, what happens in that situation?
You add them.
Yeah, I add them. So be careful with the negative charges, because those are the ones that always trip people up, because you guys forget about the whole negative sign and it adding, okay? So just keep that in mind. The rest of this really just talks a little bit more about isotopes, which isotopes are where we have their atoms of the same element. So the things they have in common, since they're the same element, that means they have the same number of protons, because that's how we identify the elements. The difference is that they have different numbers of neutrons, and therefore they have different mass numbers, okay? So a lot of times IB likes to give you symbols like this, and they like to say like, oh, which of these are isotopes or which of these are not isotopes. And so if they're isotopes, then they will have the same chemical symbol and the same atomic number. The only thing that will be different is the mass number up here, okay? And that's because when we look at their particles, they have different numbers of neutrons, okay? So different numbers of neutrons gives you isotopes, different numbers of electrons gives you ions, and different numbers of protons gives you totally different elements, because that changes the identity, okay? So what we're going to do now, we are going to do some practice with doing these symbols for isotopes and ions, because this is similar to what you guys are going to be doing on your practice assignment. So this is just like an old practice worksheet, okay? But basically, a lot of times, this is how you have to do things with atomic structure, is they'll give you information like this and you're missing some of it, and you got to figure out what all the other information is and fill it in. But they give you enough that you should be able to do that. So for example, on this first one, they gave us the atomic number, it's 17. And what did we just say atomic number is always equal to? So I got an answer here in class. Anybody online want to chime in? I give you a hint. It's right above it on the page.
The number of protons.
There you go, number of protons. So anytime they give me the atomic number, I can automatically fill this in, and vice versa. So like this one's got a 40, so I know this is going to be 40. This is a 92, I know that's going to be 92. This is a 34, I know that's 34. So if they give me the protons or the atomic number, I know that those are always the same, so I should fill those in. That's really easy to do, okay? The next thing, let's see, they gave us the neutrons on here. So I could find the mass number now, because the mass number is the atomic number plus the neutrons, or protons plus the neutrons, whichever way you want to word it. So mass number is atomic number plus neutrons. So I have 17, And then I have 19 neutrons. So what's the mass number for this one going to be? If I add those two up. Come on, guys. I know y'all can add that. I know we're all tired, but you can do it. 17 plus 19? 36.
36.
So, yeah, thank you. So 36 is my mass number. Now for the electrons, okay, what do I need to look at to figure out the electrons? There's two things I need to look at. The charge and the protons, because if the charge is 0, then the protons and electrons are the same. If the charge isn't 0, then I'm going to have to do a little bit of math, okay? So on this one, if I come over here, the charge is 0. So that means I can just fill this in. It's going to be the same as the protons. It's 17. All right. So then the last thing is my symbol. So this is where I need a periodic table because I'm going to have to look up this atomic number 17. So you will have to have one of those pulled up, on another screen, unless you have a paper copy that you have already. If you had me for last year, if you saved your stuff, you should have one in your notes. But if you didn't save it, then you'll have to look up one online. There's one linked on our homepage in the little Bitmoji classroom. If you click on the periodic table, it opens it to a periodic table website. So if I look up atomic number 17, anybody looked it up? Which one is it? So it is chlorine, which is Cl. Yeah, you looked it up. Kelly looked it up on the internet, even though she's sitting here in the room with the big periodic table on the wall. So that's how tired we are, you guys. Like, it's no joke here. All right, so chlorine symbol is Cl. Make sure, guys, on your element symbols, the first letter is capital, the second letter is lowercase, okay? The second letter is not capital, the first letter is not lowercase, and they are not the same size, okay? So, make sure that your sizes of your letters, you pay close attention to that, all right? Okay, so then that's the element symbol, but we need all of the other parts of the isotope symbol for the atom, okay? So what else do I need to include in this symbol, and where does it go? Which one do I want to do first? No, I'm talking about, we're finishing chlorine. So I'm saying what numbers do we need to put and where do they go? Okay, so Kelly says 17 on the bottom left because that's my atomic number and that's where that goes. So remember, atomic number is the Z, mass number is the A from the notes. And so the mass number goes up here on top. So that's that 36. And then if there's a charge, we would put it up here. But this one, the charge is 0. So when the charge is 0, you don't write it. You only write it if it's a positive or negative number. Okay. So that's how that one would be done. So let's do one now where we're going to go kind of the other direction. We're going to go backwards. So let's look at like number 5. Because number 5, they gave me the symbol. Now they want me to write out all the information. So from this symbol, what can I fill in first? Emmanuel, which one you want to do first on number 5? So from that symbol, what information do I have?
You have the, what's it called? The number of protons now?
Yeah, so I know because this bottom number, that's the atomic number, which is also the proton. So I can fill both of those in from that 82. All right. Marisol, what else can I fill in from the symbol? I'll scroll back up so you can see the column titles.
The atomic mass?
Okay, so not the atomic mass, it's the mass number. So, and I'm glad you said that because I will just clarify, they are two different things. Atomic mass is what we're going to talk about on Friday. That one we have to calculate. That's that one where we have to do that average calculation. And when we see it Friday, you'll probably remember it from last year if you don't. But I just want to clarify that. So atomic number, mass number, and atomic mass, those are all 3 different distinct things, okay? So make sure that you use those correctly in the future. But yes, so the mass number goes here. That's that 206 that's up on top. All right, so now how do I find the you want to do electrons first or neutrons first? I know which one I'd pick, but Kelly says electrons. Anybody else online want to do something different, or are we good with doing electrons first? All right, silence. I'm going to take that as y'all are okay to do electrons first. All right, so on this one, first off, to do the electrons, we need to fill in the charge. So the 4+, that means that this is a +4, okay? So now I know that the electrons are not going to be equal to the protons, so it's not going to be 82. So remember, I have to do the protons minus the charge. So 82 minus 4, and then what does that give me for the electrons? 78. Okay, so I lost 4 electrons. That's why I have a +4 charge. So a lot of people mix up the charges because they're like, well, how can you have a positive charge if you lost something? But you have to think about, just like we said, kind of with that math, thinking about it mathematically, we're losing something that has a negative charge. So we're subtracting a negative, and that makes our charge go positive, okay? All right, so now the neutrons. How are we going to figure out the neutrons from here? Yep, so we're gonna do, here is my mass number, and I'm gonna subtract the atomic number or the protons because they're the same number. So I'm gonna do 206 minus 82. And what does that give me? I haven't done this one. Let's see, 4, yeah, 124. So I get 124 for the neutrons. Now, one thing we didn't really do on these 2 examples we've just done is write out the name, okay? And you do have to do that on your practice assignment as well. So if I wanted to write out the name of these elements or these isotopes, first off, I need a periodic table. So for this first one, for Cl, that's chlorine. So CHLORINE. And then I need to include the mass number. So in your, yeah, so I put a hyphen or a dash after the name. And then for this one, the mass number is 36 because that's my protons and neutrons added together. So if you're asked to do the name, you do the name of the element and then the dash or the hyphen, and then the mass number is written after it, not the atomic number. I don't need to include the atomic number because I know it's chlorine. So including the atomic number, that's like redundant because I already know it's chlorine. I can look up its atomic number. What's different is the mass number, because there I might have a chlorine 36, but I might have a chlorine 35 or a chlorine 37 if it has more or less neutrons, okay? For the other one, what element is Pb? So Pb is one of those ones where its symbol doesn't match its name because the symbol comes from the Latin name, which is lead, which the Latin name is plumbus, Plumbous. So this is lead and then dash, and then which number is going to go after this one? Simon? No, Simon with us?
Is it 206?
Yes, thank you, the 206. Because again, that's this mass number over here. So this is really pretty much what you're doing on your practice today, is, you know, whatever they give you. So on some of them, you're going to have the symbol and you're going to have to tell me the protons, neutrons, and electrons. Some of them, you're going to have the protons, neutrons, and electrons, and you're going to have to build the symbol. Some of them, you're going to have to identify, like, what charge does it have and how do I know that? How many electrons did it lose or gain? So you're doing just a lot of various practice with this type of concept today. But again, this shouldn't really be new. This should be like a review, like a refresher from last year. Okay. So does anybody want to see another one, or are you guys good? You think you're good to go on your own? Or do we want to do another one?
Maybe one more.
Maybe one more? Okay, which number do you want to do?
Uh,
I'll let you look at all of them.
11.
11. Okay. All right. So 11. Okay. So I can do the protons and the atomic number. What's that going to be?
47 and 108.
Well, 47 for both of
All right, that's
those, and then
47.
and then 108 is my mass number. So that goes in that second column. Kelly says the charge is 0 because there's nothing up here in that top right corner. So if there's nothing up there, the charge is 0. So what else does that tell me? If the charge is 0.
It's the electrons and the protons are the same.
Yep, the electrons are the same as the protons. So I can go ahead and fill that in. So then all I have left is the neutrons, which we get from subtracting the mass number and the atomic number. So 108 minus 47. So that's 60, yeah, 61. Get 61. Wait, is it 61? Yeah, 61. Yeah. So that's that one. There's a second page here too, but I mean, once you start doing them, they're pretty much the same. You just practice doing them so you remember how to do it. Okay. When we come in on Friday, we will be doing the other part of this part 1, which has to do with what we were talking about earlier with atomic mass. Okay. So you do have some practice ones in your notes where you're doing protons, neutrons, and electrons. So you can practice on those as well. If you want to. But when we come in Friday, we're going to be talking about this atomic mass. And in IB, we specifically call it relative atomic mass because it's relative to an atom of carbon-12. So we're going to get into that. But just to show you, this is like these problems like last year where it would be like, this element has 2 isotopes. Here are their percentages. What's the average atomic mass? And so you always have to do the percent times the mass for each isotope and then add them together. The only catch is the percent. You have to change it out of a percentage first, so you have to convert it to decimal form. So once we go through that Friday, I'm sure some of you are going to be like, oh yeah, like that's like vaguely familiar. Okay. The only thing that's different for IB is we talk a little bit about like, well, where do they get these percentages from? Like, how do they know it's that percentage? Because there's an actual machine called a mass spectrometer that they use and they measure it. And we used to have to know how this operated. They took that out. So y'all don't have to know all the parts of it. But we'll still just kind of talk about like, how do they figure this out? Because it's kind of interesting. And so they end up with a graph that looks like this. And so the way that I would read this graph is these are my masses, or I'm sorry, no, those are my percentages. Because if you look here, that's the percent on the y-axis. And then down here, it gives me the masses. And so it's giving me the same information as like one of these problems down here. It's just presented in this graph form because this is how it actually comes, like a readout from that machine looks like this. And then somebody has to interpret it and figure out stuff. Okay, so that's pretty much it for today. Do you guys have any questions over our stuff from today? All right, if not, I'm gonna let you guys go ahead and log out and you can be working. Remember, you also have your project on Friday that's due. So don't forget about that while you're kind of keeping up with your stuff from today as well. And I will see you guys on Friday.
All right, you have a good day, miss. Thank you.
Bye, you too. Viet, I didn't see you until just now. Did you just now come in or were you here a while?
Bye, Miss.
Bye, guys.
Bye, Miss. Sorry I joined late.
That's okay.